I'm Jem Young, an engineering manager at Netflix. I created this course because I wanted people to have a more approachable way of thinking about full stack system design and distributed systems. In this course, we'll cover a common strategy for approaching any system design problem. We'll cover common technologies and components like databases, caching, and how to understand system quality. And in the end, we'll put it all together in system diagrams that enable us to scale to millions of users. Everything's a system, and now you have the tools and the thinking to design scalable distributed systems. Our first exercise, we are going to design a pizza shop. So open up your whiteboard or drawing space. You can use a notepad, pen and pencil. It doesn't matter. I'm going to use draw.io or ExcalDraw, doesn't really matter. Mainly because my handwriting is terrible and you will not know what's pointing to what. So go ahead and open those up. The first thing I want us to do is let's describe the ordering process in six steps. So we have our scope. It's a pizza shop. It's not a noodle shop. It's not a sandwich shop. It's a pizza shop. But what are the steps in getting a customer their pizza? So write that down. And then once you have that down, create a diagram showing that flow. So here's my thinking. Step one, I want to take the order. Step two, I think I want to roll out the dough. So I'm going to stop ordering. Say dough. Step three, get the thing, take the pizza. Let's put the toppings on. Step four, I want to call that baking. And step five, we'll call that box the pizza. Does this look similar to yours? Yes or no? No? What are your steps generally? Michael?
Cashier takes customer's orders, so that's first step. Second is order is paid for and sent to chef. Chef adds the order to the queue of orders. And then once the order is up, prepares it. And then that order, after completion, is sent to the register, and then the customer picks it up.
It's pretty good. That's in depth. What about anybody have anything different?
I was gonna say on my part, I think I over broke it down. I had 9 steps, and then I tried to consolidate them back together. So I could give either one of them.
I put payment as the last step on mine.
Oh, interesting. Let's draw this out. This is more an exercise in getting used to the drawing tools. So I want my dough to be pizza. So I said, lay out the dough. Then I said, toppings. All right. Then I said, put in the oven. Actually, make that a circle too. I'm going to bake it. And then I said we want to box it up. Does your diagram look different? Yeah? Is that okay? Yes, it is okay. And that was the purpose of this exercise is 1, let's get familiar with drawing tools. 2, let's understand that we're all approaching something differently. Because the instructions that I gave were pretty vague. Pizza shop, cool. Already in our minds, we have different pictures of what we're trying to do immediately. Depends on if you've worked in a restaurant or something like that, you probably have maybe a more detailed picture of how things work versus if you just order your pizza and it just shows up at your door magically, you probably have a different picture. So that's okay. It's okay to have different perspectives going into it. And that's what's going to happen largely is we may differ a little bit. It doesn't make it wrong. Because what you wrote, as long as it makes logical sense to you and you can explain that back, then it's okay. As long as the customer in the end still gets the pizza, then our steps were okay. because we didn't really get into what we're trying to accomplish or what are the details. So we got to scale up. Our original functional requirements were something like, I think it was like 1,000 users and 10 concurrent, something like that. Pretty low scale. Our very simple client server database will do that just fine. 1,000 is nothing. Our phones could probably do 1,000 if you want to make our phone a server, which someone did ask earlier about our phones as a server. So full circle. How do we scale our system? What does scale look like? Is it scale number of users, requests? We're looking at latency. The two types of scaling we're going to talk about, there's vertical scaling and horizontal scaling. And we'll go back to our pizza analogy. So we have vertical scaling. Vertical scaling in our pizza example is the equivalent of buying a bigger oven. That works, right? We want to make more pizzas, we can buy a bigger oven. What's the problem with that?
I need more space.
Yeah. You need more space. And there's a finite physical limit on our systems. You can only buy, in this case, a pizza oven that's so big. Technology just isn't there yet. Even the space in our pizza oven only fits so big. You only fit so much in a box. So vertical scaling is this idea of adding more power. But we generally don't do that if we're talking about distributed systems. But by adding more power, more memory, more capacity, we're adding more memory, adding CPUs and GPUs, adding more hard disk space. All these are making the server more powerful. And vertical scaling is easy. You don't have to change any of your code. If I say, oh man, the system's slow, what's the first thing you usually do?
Measure it.
Yeah, think higher level, much easier than that. What do you as a developer do? The system's running at peak load. What's the easiest thing to do here?
Kill it.
Yeah, I guess you could turn off the server. The thing most people are going to do is just make the server more powerful. Add more CPUs to it. Add more GPUs to it. It's the easiest thing, especially with cloud computing. Hey, let me just switch my instance type. I've done that plenty of times. There's a problem with doing that because you didn't identify the core problem, but it tends to minimize things, and it's very, very simple. I don't change any code to do that. Easy. However, there are limits to doing that. So you don't necessarily want to throw away vertical scaling because it makes sense, but horizontal scaling is about real scaling. So instead of going bigger or up is what vertical scaling, we go sideways or horizontally. We add more pizza ovens. Easy, right? What's the theme of the day?
It depends.
Trade-offs.
Trade-offs. Depends, yeah. There is a trade-off here, which we don't talk about. People often don't talk about it in system design because they're always thinking about scale. And when you think about scale, it's almost always horizontal scale. But we want to have a critical eye here. We forgot about when we're actually running our service in our system, someone's got to operate that. And in the case of our pizza, building a pizza store, pizza shop, pretty easy. You got one chef, one big oven. If you add another oven, an even bigger one, it'd still be just one chef. Easy. But now you have a bunch of chefs you have to manage, which means you need to hire something or have something to orchestrate all these people. This means complexity. So horizontal scaling, again, is not a free lunch either. You're adding more complexity to what you're doing. So the default is always, I'll just horizontally scale. Yeah, consider if that's the thing you need to do, because now it's going to get harder. When you get really, really hard, you get into things like Zookeeper or distributed messaging on how to manage all of these. And there's entire software systems that's all they do is manage complexity of distributed systems. So vertical scaling, more power, better components, a bigger server. Horizontal scaling, more machines. I talked about pros and cons. Again, it gets a bad rap. Just adding a bigger server, easy maintenance, but you're going to approach the physical limits of hardware. GPUs and CPUs can only get so fast. And when you only have one big server or a few big server, what happens? What's the danger there?
The request throughput gets bottlenecked elsewhere.
Could be, yeah, that's true.
Fault tolerance.
Yeah, the resiliency is down because instead of one, like distributing your problems against a bunch of servers, where if one goes down, you can handle it. You now have maybe 5 or 6 servers. And if one of them goes down, that's a portion of your network, a large portion. And it's also expensive to scale up and scale down because instances aren't free. And the bigger the instance, the more it's going to cost you on AWS or Azure or Google Cloud or something like that. We have a video processing service. What does it need to do?
Take the source video.
Okay.
If we're splitting audio and video tracks, then it might have to do that and store those processed things somewhere.
Transform them into the formats that we want to store them in, or to serve them in.
Okay. I'm buying that. So actually, we create that. Let's write out what we want to do. We could just build services, but let's talk about it just a little bit. Enhance. All right. So for video processing, we need to, we'll say split the audio, extract audio. And we need to convert source into, say, various formats.
And then grab the thumbnails here too, I suppose.
We need to create the thumbnails too. Good call. Okay. What's the trick here?
We need storage for processed audio and video.
We're not, yes, we do. We're not there yet, though. 'Cause we haven't done that yet. Or is the video process service doing all that?
That's what I was thinking.
It could. We could write it like that. I'm open. Actually,
Could have kind of a mediator service that handles the initial, when it gets the upload, it gets the original video, and then it passes that to the other services that maybe handle audio. It looks like that's what we'll be going.
we could have the video process do that. Yeah. And then so we could just say, hey, the video process service is converting into various formats. Does that make sense though? Is that going to be a very expensive task?
At a certain point, we probably want to throw some async workers on that thing,
Yeah.
but
What? What? We were just talking about async and we did a video. Yeah. So why have one service do that? Because now it's the center point of all the performance issues. When we know what's the job, there's actually multiple jobs. We'll say there's 4 formats we need to convert it to. It actually doesn't matter too much. So that's 4 jobs essentially it needs to dispatch. That should be a worker pool that does that. And then when they're all done, it notifies something to let us know that's all complete. Yeah?
Kubernetes time?
All Kubernetes. So let's create how did I make that fancy
Does
format?
the service become the queue, or do we want a service to create and manage the queue? Probably not.
You want something to manage the queue. You don't want the service to manage that because then now it's doing a lot. Extracting the audio, dispatching the jobs, still creating the thumbnails. You want to delegate that out as much as possible.
Rabbit or Kafka?
I don't know. Call this conversion broker. Doesn't matter. And we'll give it a. What do I use for a queue? That one. Put in the queue. Put a couple of them in there. Like that. Okay. pretty good. So now, this is going to pass it some jobs. We'll just list what those jobs are. So it's going to say convert to 4K, convert to HD, something like that. We're cheating a lot, but it's okay, et cetera, et cetera.